Hi guys, welcome to the channel. So we were discussing about the absorption and intensity shifts, and today we are going to talk about the alpha beta unsaturated compounds and the change in N to pi star and pi to pi star shifts in these type of compounds. So we will take one alpha beta unsaturated compound. This is R1, R2. Suppose we have here R3 and here we have R4. So this is alpha beta unsaturated compound. Now we will look at the energy profile of N to pi star transition of this compound in water and in hexane. So we will take two different scenarios. First we will take this compound in water and in hexane. So here it will be in hexane. And here it will be in water. Now suppose we have this compound and first we are taking up the solvent as water. Okay, so if we have the water molecules, like this, so what happens is, if we have the water molecules, then this hydrogen can do bonding with this oxygen via hydrogen bonding, right? So if we have water molecules, then we can have these type of solvent solute interactions, right? And it will leads to what? It will leads to stabilization. Stabilization of what? That we will see. So in case of hexane, there will be no solvent solute interaction. This we have studied right now. Now in case of hexane, suppose we have N here and pi star here, right? This is the energy difference in case of hexane, right? Here no solvent solute interactions are there. So if we take the case of, suppose, water here, suppose again if we assume that we have these two energy levels of N and pi star, but in case of water what happens? We have solvent solute interactions. So due to these type of interactions, what happens? There is stabilization. Due to stabilization, this N shifts to lower energy. Due to stabilization, energy of this N decreases. Now what happens? Because the energy has decreased, now overall energy gap between N to pi star increases. So this will be the energy gap in case of water as a solvent, right? I hope this part is clear. We have solvent solute interactions in case of water as a solvent when we have alpha beta unsaturated compounds. So these solvent solute interaction leads to stabilization. If we have hexane, then we are not able to see such type of interactions. So if we have this much energy gap in case of hexane, then in case of water what happens? Due to these type of interactions, this N decreases, right? The energy of this N decreases and the overall energy gap increases in case of water as a solvent, in case of alpha beta unsaturated compounds. So overall what has happened? Overall we have observed in case of N to pi star transition, the energy gap between N to pi star transition is more as compared to the energy gap in case of hexane as a solvent, right? This is one thing. And the other thing, we know that E is inversely proportional to lambda, right? Using the formula, E is equals to hc by lambda. Now E is inversely proportional to lambda. That means if E of H2 is greater than E of hexane, then it will be reverse in case of lambda. That is, lambda in case of H2 will be less as compared to lambda in case of hexane. So same solvent, if we take water as same solute, that is alpha beta unsaturated compound, when we take water as solvent, wavelength will be less, lambda max will be less as compared to the wavelength when we take hexane as a solvent, right? These two are important observations in case of n to pi star transition in these type of compounds. Now we will look for the pi to pi star transitions, right? This was all about the n to pi star transitions. Now we will look for the pi to pi star transitions. So these n to pi star are comparatively less intense transitions that we already know as compared to the pi to pi star transitions, right? So now we will move on to the pi to pi star transitions. Okay, so now we will discuss the pi to pi star transitions. Now suppose in this case we have two energy levels, right? Pi and pi star. Okay, now again we have taken two solvents, right? That is water and hexane. These are the two solvents and we have taken that same alpha beta unsaturated compound. Now in that compound we had the carbonyl bond, right? We had that carbonyl bond. Now what happens, we take up the ground state and the excited states here. We consider the ground states and excited states. Now what happens in those states, we assume that this carbonyl bond looks like this in ground state, and in excited state what happens, bond kind of elongates so that it could do the interaction with the other molecules. Other molecules, by other molecules means I mean the solvent, right? These type of interactions. Only when this bond elongates, that is, it becomes a bit weaker than the bond in the ground state, then what happens, these type of interactions happen, right? This is in the ground state and this is the carbonyl bond in the excited state when it is going to interact with the water molecules. So this is what we assume theoretically what happens. Now here the bond is more polar as compared to this one, right? This is more polar bond. So hydrogen bonding is more in case of excited state, which leads to the stabilization of the excited state. Now because here due to these interactions this excited state is stabilized, so what happens, the energy of this pi star decreases a bit. Where it is happening? It is happening only in case of water as a solvent. This is not happening in case of hexane as a solvent. So when we have hexane as a solvent, this is the energy difference, right? This is in case of hexane. But when water molecules interact, what happens? Due to these interactions, energy of pi star decreases, and overall what happens? Overall we have this much energy gap between pi to pi star transitions in case of water molecules as solvent, right? So here what we have observed is, here energy in case of water is less as compared to energy in case of hexane, right? So again, if energy of water is less than the energy in case of hexane, then what happens in case of lambda? Just the reverse. lambda in case of water is greater as compared to lambda in case of hexane. Right, these are the two observations in case of pi to pi star transitions in alpha beta unsaturated carbonyl compounds. Right, so far that's it for this video. Thank you so much for watching.